In the last session, we were talking about acids, okay? What I said I wanted to do is I wanted to go through some typical reactions that you need to know involving acids, okay? I just did a couple here. Let's just go through them quickly. I would suggest writing them down, okay? Just the generic. You don't have to know the ones I've done as examples, but first of all, number one. Let me just go to there, so that if I change, okay, back to there. Number one is a metal plus an acid. That gives us a metal salt plus hydrogen gas. Okay? Hydrogen generally is a gas. So let's take a metal. I took calcium solid plus H2SO4 aqueous, because the acid is in water. It has been diluted. When we put it into water, it's diluted, right? Just like you do with concentrated cool drinks and stuff, right? In Europe, it's called a squash. So what do? We pour a little bit, that much in, and then we top up with water. We dilute it. And you dilute it so much to so much in a ratio, don't you? Okay? That's important. So it's dilute, so it's aqueous. Now, look what happens. We have got calcium. Over here, what have we got? This acid, when it's in water, does this. It dissociates in water to give us 2 hydrogen plus ions plus an SO4 minus 2, right? This then goes and you end up getting a metal salt. So there's the metal, there's the salt. So these two just swap partners. That's all that happens. So we end up with calcium sulfate. Now I must check first. This is minus 2 plus 2. So therefore, yes, they will go together as is. And hydrogen gas H2 as a gas. And that will be aqueous if it is soluble in water or not. Okay? Can you see what I did? I actually just split the acid into its 2 ions. It's got 2 H pluses. They come from 2 hydrogens. When it's in the water, it releases 2 H pluses. They actually join onto an H2O molecule called a hydronium ion. It actually does this. H2O plus the hydrogen proton becomes something called H3O plus. That's called the hydronium ion. Okay? Don't worry, it comes up next year. Okay? Not a big deal at this stage. Right. Moving along. What happens next? The second one that we're going to do. Now we've got a metal hydroxide. Metal hydroxide plus an acid. Okay? Hydroxide is an OH, isn't it? Okay? So it's a metal hydroxide, okay? And an acid, all right? What is the metal hydroxide? It's actually a base, isn't it? Plus an acid goes to a metal salt plus water. This metal hydroxide could also be written as a base plus an acid. This is a special type of reaction. It's actually called a neutralization. Neutralization. The acid neutralizes the bases. That's what happens when you've got acidity in the stomach. Too much HCl, too much tummy acid. You take an antacid. All it is it's kind of like a metal hydroxide, right? Calcium carbonate will do it as well. It'll also neutralize it, giving off a gas. But essentially what we've got here is we've got a neutralization reaction. So let's take, for example, metal hydroxide, KOH, plus HCl. Whoops. Sorry, my HCl. That becomes, when this goes into water, we've got K is going to join with the Cl. KCl plus, this is left, isn't it? Okay, the red one, this is left, and it forms water. Okay, plus water. And it is balanced in this case, okay? Let's have a look at a different one, okay? Let's have a look at this one. 3. An acid plus a carbonate. As I say, these are all standards, okay? The quicker you know what they go for and what happens, the better. This goes to, once again, a metal salt plus carbon dioxide plus water. Okay? What do we do? Quite straightforward. Acid, let's in this case take phosphoric. H3PO4 plus, let us take here magnesium carbonate. Now it goes to a metal salt, MgCl, but hang on, that's a +2, this is a -1, so we need 2 Cl's. Remember, they're going to give it to you in words, and you have to write it down. So always go back to the valencies, right? Always go back to the valencies. And that will then give it to you. Okay? That is why I know I'm stressing it, but the table of anions and cations and polyatomics is critical, right? Okay, let's move along. Plus carbon dioxide, CO2, plus water, H2O. Phosphoric acid. Now, we've got to balance this thing, so I just want to remove my little bits and pieces over there. Okay, let's have a look first. What do we say first? We say, right, let's take the metals, Mg, okay? MgCl2, okay? Right. What do we do now? Okay, metals are there. Next is P or C, okay? How did I get magnesium chloride? Okay, that was with HCl. Ah, silly me. I've mixed up two of my equations. My apologies. But no, let's do it. It comes to the same thing. I just made a mistake there. Sorry, my bad, guys. Magnesium and PO4. But PO4 is a -3. So I've got here, let's have a look. Mg plus 2, PO4 -3. Right? What do we get? Now, let's have a look here. Mg plus 2. It means I've got to have 3 of these and 2 of those, doesn't it? Because I've got to have Mg plus 2, Mg plus 2, and another PO4 -3. That's -6 plus 6. So it's Mg3 PO4 2. Right? Can you see that? Okay. Mg3 PO4 2. Okay. Okay. And now, what is the next step? Right. We said, okay, we've got that. Now let's have a look. Mg, so I need 2 of those. 2 Mgs. Okay. And I've got Ps. I've got 2 Ps there. So I've got to have a 2 there. So now I've got 2 Ps, 2 Ps, 2 Mgs, 2 Mgs. C, I've got 2 Cs. I've only got 1 C there. So I need another C, another one over that side, right? And we're going to go through this process over and over again. So let's have a look. I've now got, now next one we said, okay, we're going to look at hydrogens. 6 over there and 2. Okay, so we need a 3 there, unless I'm mistaken. Oxygens, we've got 8, 6, and on this side, we've got 8, 4, oops, where did that go? 8, okay, 4, and 3, okay, 10, whoop, sorry, 3 oxygens. Let me just check myself. This is what happens when you have pre-do one, okay. H3PO4, that's right, so we've got that. H2O, CO2, magnesium phosphate is MgPO4 is 3,2. Kevin, sorry guys, I didn't count properly, did I? Look at the magnesiums, there's 3. Okay, this is why one's writing should actually be clear. I've crunched myself. Mg, I've got 3 magnesiums. Okay, so I need a 3 there. Okay, so I've got a 3 over there. Okay, what do we do next? We say, okay, P, I've got 2 P's, so I need a 2P there, don't we? Okay, C, we've got 3, so we need 3 C's there. Let's have a look now at our hydrogens. We've got 6 hydrogens here. Okay, and over here, well, I've already put a 3, so I've got 6. All right, so my hydrogen should be balanced. Okay, what do I do next? I say, okay, oxygens, I've got 8, and 9. Okay, which is 17. This side I've got 8, 6, 3. 8, 9, there we go, 17, right? So that's a balance. That's quite a difficult one, by the way, all right? And there we've got it balanced, okay? I'm glad that we did that. So that gives us, there's the balanced equation, okay? The acid and the carbonate. Quite a difficult one, in fact, that we chose there, all right? Now, what happens, what does this mean, okay? That means that we're getting a carbon dioxide, and carbon dioxide is a what? It's a gas, right? That's what we get, okay? Those are some of the basic ones that we're going to be, that you've gone through, right? I just want to put this into my file. Okay. Now, essentially, we are going to deal here with different types of reactions, okay? Let's just have a look at types of reactions. Types of reactions, okay? We've got 2 basic types. One is going to be ion exchange. And number 2 is going to be what we call redox. That is oxidation, reduction. Oxidation, reduction reactions, okay? These involve here an ion exchange, okay? We're going to have 3 different ones. Precipitation, gas forming, and finally, acid and base. Okay? Gas forming and acid and base. Acid and base was neutralization. We've done one. Gas forming is the acid and the carbonate, right? Which is where we form either hydrogen gas, we can form CO2 gas. Okay, those are gas forming with an ion exchange. Precipitation I haven't done, all right? What's a precipitate? Well, it's actually something quite straightforward, all right? When you mix certain things, some things are soluble and some things are insoluble, okay? Some things are soluble and some things are insoluble, right? What I'm going to do is I'm rather going to stop it at this point and do 2, just to cut this one at this point because it's going to go way over time if I have to go and try and do the whole thing in once. So rather, let's turn to the books and look up this solubility, insoluble. There's a table in your books showing which is soluble and which is not. Let's refer to those and we'll talk through the solubility and the ion exchange process. I'm sorry I'm cutting it short, but otherwise I'm going to go way over or I'm going to start rushing. So I'd rather cut it now and then we'll go on to the next one, which will be number 17, basically we're going to talk about solubility and redox. Okay. I'll see you back, well, when you've got your stuff. I'm sure I'll be ready whenever you're ready. I'm ready. I'm on your screen.